Good evening, everyone. Tonight I'm going to talk to you a little bit about managing Amazon ECS clusters. So, who here has used ECS, first of all? Okay. Probably half? Okay. Who has used Docker before? A bit more than half? Okay, cool. So, what is Amazon ECS? It's for those that aren't aware, it's a container scheduler effectively. So, if you've ever spun up a Amazon EC2 instance on AWS, those EC2 instances provide the cluster resources, CPU, RAM, and everything to ECS, and then your ECS then will allocate tasks and work that can be run on those EC2 instances. Those tasks obviously run in Docker containers. So a little bit of terminology, again, for anyone who hasn't used it. So a container instance is just the general EC2 instance running the Amazon ECS agent. Now, the ECS agent is it's an open source utility that is written and developed by Amazon to talk to their APIs. It's written in Go, and they provide a binary version as well as the source code for people that need it. And a cluster, so it's just a group of EC2 container instances in a single AWS region. So you can spread those between availability zones and run your workloads on there. A task definition is it's a description of your app or your service containing one or more container definitions. Now, a container definition will be your image, your any environment variables, any configuration, how much CPU and memory to allocate to that container, everything like that. A task, is just one instance of a task definition, and you can have multiple instances that run across your cluster. A service allows you to specify how many of a task you want to run. So you get to set a desired count. Just recently, Amazon has introduced the ability to scale that desired count up and down based on various CloudWatch metrics. So from there, you can then say, I need 3 of this application now, but I've now got some extra loads, I now need 5 of them. As long as you have enough EC2 container instances to spawn those on, they will run across that infrastructure. And then, obviously, a container is just a Docker container that was created as part of the task. To clarify, never mind. So this gives you a bit of a picture of the topology. Doesn't come out great on this screen, but so you've got your internet comes into an ELB. This diagram splits the ELB between availability zones, but generally it can just be a single ELB for example's sake. Then you've got your various container instances, so 2 on one availability zone, 1 on the other. You can generally you try and do them equal, but it's not essential. You then have Docker on each of those container instances, which then runs the various containers in each task. So when you spawn a task, if it contains 3 different containers in it, those 3 containers will be spawned on the same container instance together. And then if you spawn 3 of that task, you'll get 3 sets of 3, basically. That could be, you might have Nginx and then PHP and then, I don't know, let's say you were as opposed to running a shared Redis, you were running a Redis per instance. You might have those 3, running on each node. And then each container instance runs that ECS agent, which talks back to ECS via an API, and then ECS acts as that sort of bird's eye view of what resources are out there, what needs to run where, and everything. So, if ECS is managing what running tasks I have and where they all need to be, what manages the software that resides on those EC2 container instances? So, for those who haven't heard it before, treat your servers like cattle, not pets. Once you're doing so correctly, it makes life a lot easier. So you don't need to give them any names. Any identifier is fine. Generally, you don't want to have any kind of information on the server that you can't obtain from somewhere else centrally. So that could be logs for system or application, or any kind of system metrics, anything to do with the machine, CPU, RAM, disk, whatever it may be. Per container metrics are also really good if you can ship those off to somewhere centrally. ECS does some of that by default right now. It does, I think you can get the CPU and the memory for any given task, but you can't get anything more, whereas if you interrogate the Docker daemon locally, you can get a lot more granular, and then there are other tools you can run on your container instance that then you can ship those metrics off. Things like CAdvisor or something like that. And yeah, finally, minimizing SSH access. So generally, if these instances are cattle, you shouldn't need to be logging into individual instances on a regular basis to do things. Generally, they're just out there, they've got some work, they do some things, and then they send everything you need back to wherever you need to look and analyze centrally. So occasionally you'll get something weird, you haven't shipped some metric off to somewhere like Graphite or something like that, or CloudWatch or anything, and you might need to SSH in. So feel free, you go in, if you haven't disabled SSH, that is. But be mindful that anything you do on there may not be persistent if you're treating them in the way that I'll go into shortly. So troubleshooting is fine, but you would want to propagate whatever change you made to fix whatever problem you had back to some kind of image build process. So the upside to doing it like this, if you're on an individual instance and you're trying to fix some weird problem and you break it, just terminate the instance, just spin up a replacement. Easy. So on ECS, there is a you generally will you run your EC2 container instances, and you've got to pick an AMI to do that. Amazon distributes what they call, I think it's the ECS optimized AMI, which is an official Amazon Linux, if I'm correct. AMI, it includes a certain version of Docker that they support, a certain version of the ECS agent that they support, and a few other little things on the system. If you're starting out with ECS, it's definitely the faster way to go. But okay, you'll find down the track, once you start to use it a little bit and start to try and deviate from something, some specific way that ECS wants to do something, you'll end up needing to customize that. So in that scenario, you can use a tool like Packer to build images. So I'll give you a little quick look at what that might look like. Actually, I have that open right here. So, this resolution is so bad. Can I full screen this? What was it?
Isn't it in view full screen?
Yeah. There it is. Okay. It's not amazing. Wow. Is that worse? Okay, so I think you might be able to read it better if I do that. So Packer allows you to basically declare what an image build process looks like in JSON currently. There's talk that might change away from JSON to something else, but whether that'll happen in a hurry, I don't know. So things you do, you have a concept of builders, and they also have provisioners and post-processors. So part of the builder would be you specify a source AMI, which might just be a vanilla CentOS, Ubuntu, Debian, something like that. And then a provisioner will go a bit further, and I'll go into that shortly. And then at the end, it will shut it down and spit out an AMI. Now, this is really bad to see this, but I'm going to improvise here, and I'm going to put this in a shell so that everyone can actually read this. Okay, is that readable?
Yep.
Okay, so that's an example of what a very, very basic Packer build might look like. So yeah, as you can see, it spins up any temporary resources it needs to spin up a source AWS instance, connects right around about here, just under line 12, is normally where any provisioners would occur. So that would, run anything you need to run on the machine. After that, stops it, creates the AMI, and then outputs it as an artifact. the post processors can send that AMI ID to various places. I currently use a post processor that drops it into a file template on the system, and I use a different tool, which I'll get into shortly, to utilize that AMI. So, okay, so if you're building a custom AMI for ECS, a few key principles. If anyone was here last month, I did mention a few of these in the open space, whatever it was. But yeah, I try to bake as many of the underlying requirements as I can into my AMI. That's not necessarily application requirements, that's more things to do with actually getting that instance up and running. Like if I need to install the ECS agent, I want to pre-install it in the packer build process. If I want to get Docker installed, I want to pre-install it in the packer build process. One of the main benefits of that is minimizing that instance startup time. So if you decide you need extra resources in your cluster, you will, sorry, I thought I missed a slide, but never mind. You want to make sure you can start them up quickly, and yeah, anything you can do to avoid that just-in-time work, the better. So just-in-time versus ahead of time. Anyone that's done anything with software compilation will probably have heard those terms. And yeah, minimizing external startup dependencies. So if you're using an auto-scaling group to start these AMIs, to start up N instances of this AMI for your cluster, if any of those external startup dependencies are down, chances are your instance is just not going to work. It's not going to do what it was designed to do. So anything you can do to make that instance autonomous from boot time to when it can actually be allocated tasks by ECS, the better. Now this can include things like master servers for config management systems, and there's a bit of a debate about whether that's right or not, and I'm happy to talk about it offline if anyone would like to ask why. Things like remote Git servers. It's common where sometimes people will boot up instances in an auto-scaling group, and as part of the startup, they'll do a git pull from some repository to update the instance. If that Git server's offline, what use is it? Because, and it becomes a single point of failure for you. So, okay.
It can also be newer code too as well.
What was that, sorry?
You can have a different version. It does a git pull, it's a different version of the others.
That's right. Yeah, that's right. It's. I'll go into that topic a little bit later in the talk, but there's a lot of issues with doing that. So this gives you a bit of an idea of the workflow that I currently follow. We use this at TED to deploy out our Docker infrastructure. So I have a base AMI, put it into a packer builder with a heap of shell scripts and config management. It's a bit of a combination of both right now. And then the output is I have an ECS AMI. I can do that anytime I need to do it and just spit out an AMI. From there, I mentioned I have a post processor in Packer, which just takes that AMI ID and puts it into a file for me, which then Terraform can read. Now, Terraform, has anyone here used Terraform before? Couple. Okay. So, Terraform's a really interesting tool. If you haven't used it before, it's definitely worth a try. I will show you a couple of examples too. I've got a few of our TED examples that don't have anything sensitive in them that I can easily show you on screen. So from there, Terraform will actually talk to the AWS APIs and build out the various things that I need to spin up a cluster. So that will be an auto-scaling group, which in turn will spin up some EC2 container instances. It'll also spin up an ELB for me to verify the health of the instances in that auto-scaling group. It also does things like sets up. I can use it to set up alias records for Route 53 to certain ELBs. I can use it to set up a whole heap of other supporting things around my cluster effectively. One thing I will note here, the ASG Health ELB. So when you spin up EC2 container instances with that ECS agent installed, it exposes a web server on 5.1.6.1.8.7.8 from memory by default, and from there there's a couple of URIs you can hit. One of them /v1/metadata is it's a very basic output that it doesn't have any penalty to run it against that ECS agent. It's all local. You can run it as many times as you need to. So it's a good endpoint to hit as a health check. So by an auto-scaling group, by default, won't really know if an underlying container instance is healthy or not unless it has an ELB attached and the ELB has the health check. So from there, I can say, I don't actually serve any traffic on that health ELB. I just use it to link the health check to the auto-scaling group. From there, if any of the instances aren't reporting, a 200 on that URI, it will be, I know something's wrong with the ECS agent, and I probably want to terminate the instance and spawn a replacement at that point. So I'll divert a little bit now. Did I hear there's a lightning talk?
Yeah, I'm going up to basically a case study of our ECS.
Okay, cool. Are you going to do any example deploys?
Yes.
Okay, cool. So I won't need to touch too much on these tools, but I'll...
It's probably a lot different to you.
That's fine. So, okay, there's obviously a...
If it
I
helps,
think I missed some slides. Never mind, I'll see if I get it. I'm so sure there. So you've got a few different ways. Once you've obviously got that cluster up and running and you've got some instances and they've reported back to ECS, I've got this much CPU and this much memory, give me some work. You want to deploy your app. So you've got a few different services or deployment tools you can use to deploy your services. ECS CLI is one that's written by Amazon. It takes Docker Compose YAML files as an input, and then from there, as opposed to spinning it up with Docker Compose, it will talk to the ECS APIs and spin up, the equivalent application definition. There is also CloudFormation can also do it. Terraform has resources for an ECS service or an ECS task definition, so you can specify those. And I can show some examples. I'll see how I go for time. The alternative is using either the AWS console or the AWS APIs to write custom deployment tools. Within TED, we actually have a custom deployment tool written in Go, which talks to those ECS APIs to perform those deployments. It does a few nice things like watching to make sure enough containers have started and make sure they haven't abruptly exited and things like that, which can happen and you can end up in loops with ECS the way it stands right now. Okay. So there's a few caveats about ECS. As of today, last time I mentioned a caveat, which was I think a month ago, it had been fixed the week before. So I say as of today. ECS CLI does not support creating services with an ELB attached. So when you create a service, and this goes into the second item, there's you can only link a single ELB with a single service as it stands today. The downside to this is there's a cost penalty of like $20 a month if you're running it in Sydney per service you're running. So straight away you think, oh, well, I've got all these EC2 instances, now I'm going to put all these things in Docker on ECS, and that's going to rationalize the number of EC2 instances I need, and I'll improve the efficiency, and then there's this $20 penalty per service that you've got. Hopefully that will be improved at some point in the future. The main problem is ELBs are not vhost aware. They only can have a single, well, each listener can have a front-end port and a back-end port. They can't go to dynamic back-end ports. They can't route traffic based on the host header, anything like that. So really, it requires an improvement to the ELB to make that a reality. But yeah, in turn, because what doesn't help obviously is if you want to create one service at a time with one ELB at a time, ECS CLI won't do it because you can't attach that ELB. You've got to use something else to do it. So Terraform or CloudFormation will do that. Now, this workaround that I've mentioned here, we do this within TED. It's basically where you have a single ELB at the front, and then you point it at a ECS service which runs either Nginx or HA proxy or something, with a service discovery tool behind it that then can detect what services you have out there, what vhost they're on, and what IP and port they're listening on. And then it effectively shards outwards down below, and so all your traffic comes in via a single ELB, and then you end up with a host-aware load balancer. So you've just got two layers. If only ELB would do it natively, but yeah, we do it with HA proxy and console currently, with console template. So, and yeah, that works all right. So,
What's the advantage of keeping ELB in place in that scenario?
well, so right now, an ELB, all of your ECS container instances don't have any known IP. So straight away, you've got to manage DNS to those instances otherwise. And you could probably do something where on instance startup, you talk to the Route 53 API and manage that DNS record. I've actually written a tool recently which I don't think I've open sourced it yet. It's in a private repo. It's ready to just tick public on, which binds console as a service discovery tool with Route 53 and ELB, so you can, when a new service appears, if we have some service and it's like servicename.ted.com and we want to add a DNS record for that, it will detect the service in console and then add an extra alias target in Route 53 for it and point it at the ELB that I've configured. And it's stateless and it just runs, and so we can deploy new services and DNS is just automatically there in 30 seconds. We had to do that as opposed to using wildcard DNS because we had some stuff on ECS, some stuff not, and I couldn't just afford to wildcard start.ted.com to ECS. So I thought I'll at least do something that's a bit more granular. So we'll add individual records for individual services. So the DNS problem is one of them. The next thing I considered is using that tool to just modify Route 53 and not even add alias tags from the ELB, but just point them at HA proxies. And then I could get rid of the ELB altogether. But for now, it's kind of serving its purpose. It does cross-zone load balancing stuff. Amazon does a little bit of magic on the networking side with it, probably makes it a little bit more resilient, so I've left it in place for now. Yeah.
There is also the fact that there's this tiny little bit of magic there going on that ELB can tell ECS to kill its tasks if they don't succeed.
Correct. There is no independent health check mechanism within ECS. It's just like with an autoscaling group, you have to link an ELB which does the health check. So, yeah, and that's the other.
We're still eating that $20 cost
because it gives you the health checks. Yeah. Right now, I have the upside that if a service goes away, console knows about it within a split second. Console template updates HA proxy within a split second, and then it does a reload. There is another load balancer out there, and I was speaking to the author of it last month, which was really interesting, called Fabio. Has anyone used the Fabio load balancer? So that. What was that? Yeah. It's written by some people within eBay, and you don't have to do the whole console template, rewrite a config and reload it. It just talks to console natively, and automatically just spawns vhosts in memory. So yeah, the other one of the other caveats with ECS is it doesn't rebalance your tasks to fill spare resource gaps. So if anyone's heard of the term bin packing, you can't. It won't do that for you. You have to terminate an instant. Well, you have to terminate tasks, and it'll then try and find the next optimal place, but it won't go and proactively terminate tasks and bin pack automatically. So there are other schedulers that will try and do that a little bit better, but I'm hoping ECS will do it at some point. And as you can see, I've put GitHub issues for each of these issues with pages full of +1s and yeah. Okay, so to go back to managing your AMI. So what things should you bake into your AMI? You might want to do an initial config management run. I'll touch on it in the next slide why I would only do an initial run, but we currently use master chef to do that. We also use some shell provisioners, and we do a few things like that. We install some stuff. We install Docker. The good thing is I can specify whatever Docker version I want down to revision. I'm not limited to whatever ECS tells me. Their AMI says this is the version we have. I can just run whatever I want. I've had occasions where I've had to run some relatively bleeding edge versions to fix weird problems and things, and sometimes it's handy to have that flexibility. If you have system tasks, things that you need to run on each of your ECS container instances, and let's say they're in Docker, and normally you would do a Docker pull on boot, you might just do a Docker pull at build time, just to save those couple of extra seconds on instant start. We manage those system tasks as ECS tasks, but we don't bind them to a service. We actually do, you can do a manual start task. The advantage of that is you will get the CloudWatch metrics from the ECS agent, and CloudWatch will then see the utilization of the server grow by whatever that system task is. Whereas if you just start some non-ECS managed service, ECS won't know what the resource consumption is there, and so if you then try and do something like auto-scaling based on memory utilization of 80% on your instances, and you've got these other things that are not managed as tasks, it won't know about them, won't count it towards the usage. So doing that as ECS tasks has that benefit of the extra metrics to CloudWatch. Yeah, I've got a few examples of things that, that you might want to run on each instance. Yeah. So, why I don't like running config management on a scheduled basis on my ECS container instances. And this goes for anything that follows the immutable infrastructure pattern. So, replace instead of upgrade. I think that sort of says it all. If you're just changing the versions of something on a machine, it's not necessarily immutable. It's mutable. The upside to making your image build process, the way you do, and in turn you end up with immutable container instances, is you can test the images prior to putting them into production. So you do a packer build, install all your things. You can spin up a test cluster with that AMI, verify that everything works as you expect it would work, and then put it into the production auto-scaling group rotation. You can use the same image then in your staging cluster and your production cluster. You can do standalone testing. The other advantage is canary testing. So if you've got a cluster of 10 instances, you can drop 1 or 2 instances into that auto-scaling group, and then you can rolling upgrade and rolling replace the other instances once you know it's working correctly. If something goes wrong, the rollback process is the real good thing about the rollback process is the certainty. It allows you to know definitively that your previous AMI worked. So you don't have to worry about, oh, well, I'll just downgrade the package version, and then the package manager shoots you in the foot and tells you that downgrade didn't actually work properly, and now you've got this half-working server, and you sit there scratching your head, what am I going to do? Well, I'll just destroy it. I'll just spin up a replacement. Done. Use the previous AMI version. Keep a couple of AMI versions. It's just like build artifacts in any kind of software development process.
Is that time for one question, or
yep.
You can finish?
I've got like 2 slides. If anyone hasn't, if you've got Docker images, you've got to store them somewhere. Out of those 3, to give you an idea, we use a distribution install down the bottom. It works out the cheapest by storage. ECR didn't exist when we did it either. And yeah, look at that.
Thanks, Nathan. Yeah.